Oh, hey there. You're watching BEDMAS.
Oh
Oh
no,
no, it's
it's
the
a
wizard
wizard
that
that
changes
changes
the
the order
order
of
of
your
your
DNA.
DNA. Oh, I look different now. You're watching BEDMAS.
Hello, everybody, and welcome back to another episode of BEDMAS. Hope you're all having a great day today. And before we get started, I would just like to give a little shout out to my grandparents who faithfully watch my videos. So thanks a lot. Love you guys. So in the last video, we talked about order of operations, and essentially we saw that if people evaluated two expressions like 3 times 4 plus 5 and 3 times 4 plus 5. If people evaluated this in two different ways, where if we multiply first, we get 12, add 5, and that gives us 17. Or over here, if we added first, we would get 9, and 3 times 9 is 27. So we saw that if people evaluated these in different orders, we got different results. And so the whole point of order of operations was to kind of give us a consistent method of evaluating things. And so that motivated why we needed order of operations. But then we also talked about why specifically we used the order of operations we did. And that ordering was BEDMAS or PEMDAS. And essentially that was brackets or parentheses first, then exponents, then multiplication and division. And we kind of just evaluated that from left to right. So it didn't actually matter if multiplication or division was first. And then similarly with addition and subtraction, we kind of just grouped those up. If you want a review on that, please go watch the video and the exercise video I have prepared for that. I strongly recommend you're very confident with order of operations before you watch this video. So we kind of have this idea of order of operations. But the thing is maybe for like the first time in this series, this is kind of an artificial thing, it seems like. Like before, okay, maybe we did like prime factorizations and we took a number and we split it up into prime numbers. And those seemed like a fundamental natural thing. Or when we multiplied fractions, we saw why we had to multiply the numerators and the denominators. All this seemed very fundamental and natural. But with order of operations, kind of wanting to make sure that everyone is consistent, that feels like a very man-made and imposed thing. It's like a person wanted this. It feels a lot less like we're discovering something and more like we're inventing something. And that is actually a whole argument in math. Is math invented or is it discovered? I personally think it's kind of both in some ways. But in terms of the conventions, that is all invented. So we've invented this convention of doing BEDMAS. But the question is what if we invented it differently? Would that break math? Would math look different? Or would we still be able to get consistent things? Because we see math being useful in the real world, right? You can build a rocket by using math equations. If we define BEDMAS differently, would we not be able to build a rocket anymore? So we're going to kind of explore some of that in today's video.
Evaluation using a different order of operations.
All right, we're going to start by just using different order of operations and seeing what evaluation would look like with them. For these, we're just going to basically change what the acronym is, change what the ordering of our order of operations is. So for this one, maybe let's do something like based M. All right, so brackets first, addition, subtraction, exponentiation next, and then division, multiplication. And for this, we're still going to kind of have addition and subtraction and division and multiplication being on the same tier. We just evaluate from left to right. All right, so if I had an expression like, let's say 3 plus 2 times 4 minus 8, we no longer evaluate the 2 times 4 first as we normally would. With this new order of operations here, we actually do addition and subtraction before we do any multiplication. So we actually have to do this 3 plus 2 and this 4 minus 8 first. So 3 plus 2 is 6, and 4 minus 8, that is negative 4. And then 6 times negative 4, well, that's going to be a negative number, and we get negative 24. So we see that we get something very different than what we would do with BEDMAS, right? Let's try another example. What if I had something like 3 times 2 plus 1 plus 2 squared. So in this situation, we have parentheses, right? And we actually need parentheses here in order to actually have multiplication occur before addition, right? So the parentheses, that tells us to evaluate this, we get 6. And then we have plus 1 plus 2 squared. And you might be tempted to evaluate the 2 squared here, but notice addition comes before exponentiation. All right, so then what we do next is we get 6 plus 1, which is 7, plus 2 squared like this. And then we have 7 plus 2 squared, but we have to do the addition first. So 7 plus 2 is 9, right? So 7 plus 2 gives us 9. And then we square all of that. And now we can do exponentiation now that we've done all the addition, and we get 81. Right, so this is extremely weird and maybe seems kind of counterintuitive because we're using a different order of operations. But it's entirely possible that some people along the way were like, okay, let's define order of operations. Maybe there's like an alternate universe out there where this is how they've done it. And so if they see an expression like these, everyone would evaluate it in the same way. This isn't how we do it, but this is just kind of like a mental exercise or a little exploration of what if it was like this, right? So I don't want you to get too caught up on, oh, this is wrong. Just try and have some kind of an open mind and some flexibility to this is how it could have been. All right, so let's try another one. All right, let's maybe try something like this. PMADS. So parentheses first, multiplication, and then addition, division, exponentiation, and subtraction. So in this case, we actually don't get that addition and subtraction are just super like reversible here, where we can kind of do either or. And similarly with multiplication and division, every multiplication statement will always be evaluated before a division statement, and every addition statement will always be evaluated before a subtraction statement. So let's say I have something like, all right, so let's try this. So with this order of operations, again, we still start with parentheses. So we have 5 minus 2, which is 3. And we can keep all of this stuff. Okay, so the next thing we do is multiplication. So we actually have multiplication in a few spots, so let's do all that. So 3 times 3, that is 9. And again, we can't do the division first because multiplication always comes before division in this order of operations that we're working with. So the next thing we actually do is this 2 times 4, which is 8. And then we just kind of carry the exponent along for the ride. And next up, we have addition, right? That's actually coming before the division. So we have 9 plus 2, which is 11. And then we're dividing by 8. And then we have all of this squared. Okay, so now we have 11 divided by 8, and we do that before the exponent. So 11 divided by 8, let's just write this as a fraction. So this is 11 over 8. And now, since we need the squared to apply to all of this, I'm going to just put these in parentheses to indicate it's this whole fraction squared. But remember what something squared means. It means you're just taking the number and you're multiplying it by itself. So really, we are looking at this statement here. And 11 times 11, that's 121, and 8 times 8, that is 64. So this is an example of using this order of operations right here. So now that you kind of have an idea for what this might look like, I encourage you to have some fun. Make up your own order of operations, come up with some different expressions, and try and evaluate them according to that order of operations. And maybe for reference, always evaluate them as well using the regular order of operations, both for practice, but also to kind of see how the difference occurs. The only thing I will say when you're making your order of operations, always make sure to start with a B or a P, with the brackets or with the parentheses, because the whole point of those is to be able to order things, right? And if we don't have those coming first, we can't actually specifically order certain operations or give priority to different operations. So that's kind of the one caveat with this. All right, so now that we kind of know how evaluating expressions using different order of operations looks like, let's talk about how we can actually express the same thing in one order of operations as a different one.
Expressing the same process using different order of operations.
So let's consider the statement 3 times 4 plus 5 squared. All right, so in the BEDMAS world, right, the regular way we do order of operations, we evaluate the 5 squared first, right? So that's going to be 3 times 4 plus 5 squared, which is 25. Then we evaluate multiplication x, which is 12 plus 25, and then we add these up to get 37. Now, if we were to do this in a different world, for example, maybe the based m world, All right, so this is our order of operations now. We get a different value, right? We would do the addition first, right? So we'd have 3 times, and then 4 plus 5 is 9. Then we would do the exponentiation next. 9 squared, that is 81. And 3 times 81, that is 243. So we get two extremely different things depending on the order of operations that we use to evaluate this statement. The question is how can I rewrite this statement right here such that I actually get the same thing inside of the based M order of operations world? So what do I mean by this? Here this is telling us we have to do the exponent first, then we have to do multiplication next, and then we add them. So how can I ensure that happens in the based M world? Well, we can use parentheses, right? So in the based M world, if I want the 5 squared to happen first, what can I do to make that happen? Well, I can put parentheses around the 5 squared, right? So now we actually have to do 5 squared before we do anything else. And similarly, in the based M world, addition always comes before multiplication. But if we want it to evaluate to 37, if we put parentheses around the multiplication here, that's going to prioritize the multiplication and essentially accomplish the same thing as what happened over here. Now when we apply based M to this, we can just focus on the parentheses. So 3 times 4, that is 12. 5 squared, that is 25. 12 plus 25, that gives us 37. So we do get the same thing, and we can get the same thing in the based M world. We just have to write the expression differently. So this is an extremely important point, perhaps maybe the most important point of this video. If we evaluated order of operations using a different order of operations, we can still do the same calculations. They just look differently. Here, this is saying, okay, I want to do multiplication, I want to do exponentiation, and then I want to add them together. If I want that rule to happen, I can still do that with a different order of operations. I just have to write it differently because I'm using parentheses now. In order to ensure that happens, I use parentheses around the multiplication and around the exponent to ensure those happen first, and then I add them. Over here, I didn't need them, but here I do because our order of operations is different. And this basically means that if we define order of operations in a different way, we would still be able to do all of the same math, where we can prioritize one operation over another. We just would need to use parentheses in a different way to show that we're prioritizing those things. So to emphasize this, let's try another one. Let's try and use this order of operations that we worked with here. P, M, A, D, E, S. All right, so let's see what this expression would look like if we did it using this order of operations. So multiplication comes before addition here. So the 3 times 4 plus 5 squared. The 3 times 4 doesn't need to be in parentheses because that's going to be prioritized over the addition. However, that's not going to prioritize the exponent, right? Exponent comes after addition in this order of operations. So in order to do what it does over here, where we do the exponent first, we got to put this 5 squared in parentheses, kind of like what we did over here. So different order of operations, but it's going to evaluate to the same thing again, right? So just following this order, P first, so parentheses, we get 25. And then multiplication next, so 3 times 4 is 12. And then addition, lastly, we can do that and get 37. So we get the same thing, but we just had to write the expression a little bit differently because we're using a different order of operations. So I really hope that that point was driven home, because that is probably the most important point of this video. Just to reiterate, if we write an expression in one order of operations, we can still write it inside of another order of operations as long as parentheses comes first, because we can just use the parentheses to prioritize things in the same way as what it was in the original order of operations that we were working with. And this shows that no matter how mathematicians defined this ordering, we would still get a consistent math, and we would still be able to do all of the same math as what we do. It's just the expressions would look a little bit differently with how we use the parentheses for prioritizing things.
Potential problems with different orders of operations.
So we just talked a bunch about how we can do a different order of operations and how basically they all kind of work. We can just take one and convert it into another. So that begs the question, why BEDMAS then? Why don't these other, if all these other ones work and we can kind of convert between them and we can express the same things with them, why do we really need to do BEDMAS specifically? And of course, in the last video, we talked about some reasoning for why we chose BEDMAS. It works nicely when we look at kind of these compacted operations where exponentiation was basically compacted multiplication and multiplication was basically compacted addition. Please go watch that video if you're not familiar with this reasoning. So that's one reason why we chose BEDMAS. But if we kind of look at other order of operations, is there maybe a reason why those aren't as effective? But before we do that, let's talk about an idea in math, a common idea called being well-defined. So to understand the concept of being well-defined, I think it's easiest to start with an example. So if I have 3 plus 2, I know that's going to be 5. This is what's called a well-defined statement, because what addition does is it takes the number in front of it and the number after it, and it combines it in some way, right? So this is well-defined. If, however, I did something like this, 3 plus, well, that's not well-defined because addition takes two numbers, right? And this doesn't have a second number, so this is not well-defined because it doesn't have a second number to add to the 3. Or maybe if I said 3 plus equals sign, that's also not well-defined because addition adds two numbers. It doesn't add 3 and an equal sign, right? So this is not well-defined. So this is an important thing for us to consider with order of operations, where if we do different order of operations, will everything look well defined? So to consider this, let's look at based m. So with based m, if I did something like 3 plus 2 squared, all right, well, I evaluate addition before exponentiation, so 3 plus 2 gives me 5, and then I evaluate the 5 squared, and I get 25, right? However, what would happen if I did 3 cubed plus 2 squared? So I still have to do the addition first, so I get 3 plus 2, which is 5. But now the question is what do I do with this 3 and with this 2? We don't really know what to do with the 3 and the 2, right? I could maybe write 32 here, or I could do maybe 3 plus 2 or 3 times 2. But we have no good method of how do we basically transfer this 3 and this 2 in some way into the exponent. Here it was clear because we only had one exponent we were working with. Over here, however, it's not as clear because we have multiple exponents that we're working with. So this becomes a problem where we don't know how to basically combine this statement. So inside of this order of operations, this would be a not well-defined statement. We haven't really defined how this works. Maybe someone could come along and define how this works, but you have to be careful because that could lead to maybe contradictory things. But we know in BEDMAS, this statement is perfectly fine, right? We could have 3 cubed plus 2 squared, and because we evaluate the exponentiation first, we get 3 cubed, which is 27, and 2 squared, which is 4, and this evaluates nicely to 31. But it doesn't work out over here. Of course, we can still do something like this inside of the based m order of operations, where we just use parentheses, and that ensures that we essentially are evaluating it in the same way as we are with BEDMAS. However, without the parentheses, we don't get a statement that has a lot of meaning to us. So this is kind of a weird thing where with different order of operations, statements that we were used to being able to write, actually, they don't even just have a different meaning, they just don't have a meaning. It's not a well-defined statement. So that's one potential issue with looking at different orders of operations. Another potential issue, let's look back at our PMAID's order of operations. So what if I did something like 3 divided by 3 times 2? Okay, so under this order of operations, I always do the multiplication before the division, right? So I get 3 divided by, and 3 times 2 is 6. And 3 divided by 6, well, that's 3 over 6, which is 1/2. We know in order of operations that dividing by 3 is the same as multiplying by a third, right? That was kind of a big thing here. But look what happens if I multiply by a third in this situation. Because this is all multiplication now, I just go from left to right. 3 times a third, that is 1. And 1 times 2, that is 2. I don't get the same thing. So before, in a regular order of operations, we were able to say basically that 3 divided by 3 could always be replaced with 3 times a third, right? Because we know multiplying by a third is essentially division by 3. But in this situation here, if we replace it with 3 times a third, we can actually run into these inconsistencies. So this is something we have to be careful about. Now, 3 divided by 3 is the same thing as 3 times a third, but that's only when we kind of consider it in isolation. So this only becomes true if I did 3 divided by 3 times 2, but the 3 divided by 3 is in parentheses, or that takes the precedent, that takes the priority. So if we have 3 divided by 3, we can write that as 3 times a third, and in this situation, we will be getting the same result. But that's only because we're making sure that this 3 divided by 3 is actually going to be occurring in isolation, and this 3 or this 3 isn't being taken elsewhere by some other thing that has priority over it, either by a multiplication like we saw over here with this 3 being affected by this 2 before we could divide, or with maybe an addition occurring before the division. So I encourage you to maybe play with different order of operations and see maybe what goes wrong with it, right? It's not necessarily that it breaks. It's not that it doesn't work. It's just that statements that were nice and well defined in BEDMAS might not be nice and well defined within these order of operations. But as we saw in the first 2 kind of sections of this video, we can still define different order of operations and they can still work. We just have to be careful that they are working properly.
Concluding thoughts.
So that's going to do it for today's video. I hope you found this interesting. I think this is kind of a really fun sort of exploratory video where we look at what if we define things in math differently. There's actually a lot of areas of math that do this, where it looks at, okay, what if we assume that this thing that we always knew to be true, what if it wasn't true? How does that change things? And so on and so forth. So it's a really interesting kind of type of math where you kind of consider what if it was different, and you often can lead to some really interesting results. So I really encourage you to play around with different orders of operations, see how they work with looking at how you can evaluate statements, see how you can express statements from the original order of operations inside of your new order of operations, and see if you can find anything that maybe goes wrong inside of your order of operations. What are some statements that aren't really well defined or maybe lead to some inconsistencies? And I would love to see maybe some of your results in the comments if you would like to share those. And if you have any questions, of course, you can always ask. But that's going to do it for me. You have a good one. You stay groovy, and I'll see you in that next video.
Oh, no, if the wizard that changed all my DNA changes my DNA, am I still BEDMAS?
BEDMAS.